Hi everyone, my name is Aditya. I'm a CS major. I'm studying at GW, and I wanted to create a video to help CS students who are, trying to get into this field, who want to learn about computer science and get started for the first time, and really for anyone in general. You don't need to be someone who's studying CS formally. If you're just interested in it and you've stumbled upon this video, you want to learn how to get started, get your computer set up. This is a really good video. So there are a couple things that I want to achieve here. First is I want to kind of give you an intro to the intro to CS, explain some of the core fundamentals that people would have usually not thought about, because you're going to be using your computer in a very different way starting from now, and getting used to certain terminologies and understanding how certain things work will be very useful, and it'll just make the entire process much more seamless. So I'm going to try and touch upon those things and then give you an introduction to setting up your computer so that when you actually start coding and doing assignments and stuff, it'll be much more seamless and you won't have annoying issues. So first thing is, let me talk about what computer science actually is. So computer science, you're going to be dealing with computers and how to solve problems using them. As simple as that. Now, one thing that you need to, like, it's core and fundamental to understand is what actually is a computer. Your phone is a computer, your laptop is a computer, you might have a desktop PC, that would be a computer. It can be a MacBook, it can be a Windows laptop, it can be a smart washing machine or a toaster. There are computers in almost everything. The small devices like your smart LED bulbs, those are called IoT devices, Internet of Things. So computers are there everywhere, even in your cars nowadays. So that's the first thing, understanding about what a computer is, what differentiates a computer. Usually computers consist of a couple of hardware parts. It contains some sort of a device in order to store data. It could be a hard disk, it can be solid state drive. When I say solid state, an example is a USB flash drive or pen drive, whatever you call it. So that is to store data, and usually it needs memory, something that it uses while programs run. So when I say solid state or a hard disk, that's permanent memory. So you can write something to it and then it just permanently is stored on it. In addition to that, you need some temporary memory that is used by programs when it runs. So for example, let's say I tell a program add 2 and 3, so it needs a place to store that 2 and 3 and then the value, okay, 2 plus 3 is 5. So until it gives it back to the user and it completes its task, it needs some place to store that memory. So it needs some device for that. It needs, of course, a processor to process all of this and to actually compute. So these are things that are fundamental to these devices, these computers. These are the fundamental hardware devices that these computers have. So that is very important. Then the second thing is, when you talk about coding, programming, and computers, almost everything is taught in terms of files. So understanding the file system is very important. So I'm not sure how different people have, they usually interact with their computers, especially nowadays with the internet, with the cloud. A lot of people, they just open up Google, they go to Google Drive, Google Docs, they do everything online. So you might not have a decent understanding of how the file system works. So I'm just going to very briefly explain it. So over here I have my desktop open. I'm on a Mac, as you can see, but this is very similar regardless of what operating system you have: Linux, Windows, Mac OS, anything, it doesn't matter. So open up your file explorer, or basically the app which you use to view your files, right? You usually have a desktop, you usually have a documents folder, maybe a photos folder, a downloads folder, right? So this is where files are stored on your computer. So just understand the basic file structure, right? I'm sure most of you know this, but I just want to be a little explicit. So you have a particular folder, and a lot of times you will hear the term directory and folder, it means the same. So if I say desktop folder, I could say desktop directory, right? And in this directory I have 3 files right now, you can see over here. So I can create a new file. Or let's say I create a new folder, a new directory. I'm just going to call this new. So then I can go into this directory and I can create some more files, right? So this is a basic concept that you need to understand. um, then the next thing is files and file extensions. So you have files. Usually files are of a different type, right? Now, for example, if you have a file that ends in .docx or doc, a doc file, that's usually a Word document file, right? You need a proper application in order to open it. If you don't have Microsoft Word or any other compatible program installed, that file is not going to be able to open. Like, your operating system doesn't know what to do with it. So you have stored data. That data lives on your computer, on your hard disk or your solid state drive, but you the the computer doesn't know what to do with it. You can tap on it and try to open it, but it needs to take the data and do something with it. It doesn't know what to do with it. So it needs an application in order to open it and do something with it. And that is what Microsoft Office is. So it that so this depends on what type of file you are writing. It depends on the file extension. It depends on what type of file you're writing, right? So when you write code, it depends on that too. So let's say I write Java code. Usually it'll end in .java. So I can create a file called myfile.java, right? And I can write my code in it, save it, and I need a program that's suitable in order to open that. Now, if I have Microsoft Word, I need a suitable program to open Microsoft Word. So that is something you need to understand. And next thing is, usually when we code, we are working with simple text files. Now, to open a text file, please do not use Microsoft Word. That's overkill, and I mean, it's not even meant for this, right? All you need is a simple text editor. Now, on Mac, I think there's something called TextEdit. So TextEdit is an application that you can use on Mac. On Windows, there is a default application called Notepad, and usually on any operating system there'll be some simple text editor. All its job, its one job is to open up the file and display the contents. Plain, as simple as that. You type in the apple is red, it'll give you back the apple is red. You can edit that, and you cannot do any sort of formatting on this. You cannot make the font bigger, you cannot make it bold. I mean, like, if you want, you can make the font bigger, but it's not going to remember. You close the file and open it again, like, it's not going to remember. It doesn't save it. You can't make it bold, you can add images, you can't underline it, you can't make it italics, you can't change the font. So these kind of formatting options that you have in a Word document, you're not going to have over here. It's just plain text, right? So it's as simple as possible. That's how your source code will be. And the next thing is, I want to show you how to interact with your computer using the terminal or the command line. A command line is another way to interact with your computer without graphics. So normally you use your mouse, you have these applications visually you can see, you point and click. Before all of this, before we had monitors with these advanced graphical features, people used to just stare at this blank screen and type into the prompt. So they would type commands with letters, and then they would execute these commands and the computers would talk back and work. So that's what we're going to do. So on Mac it's called terminal. You can search for terminal. On Windows it's called command prompt or PowerShell. On Linux it's a terminal. You can open this up. So you can do a couple of things using this. For example, if you want to see the files in this particular folder or directory, you can type ls or dir on Mac. So we type this, it lists the folders. If you want to go into one of these folders, I can use cd, which stands for change directory. So change directory, desktop. Hit enter. It's going to change directory into the desktop. You can see it says desktop over here now. I can type ls again, and it lists the files over here. Cool. The reason you need to know the basics of using the terminal, the command line, is because it's very efficient in a lot of scenarios. So when you code, you will have to compile code, you will have to run the code, you will need to run test cases. There are a lot of small tasks that you will have to do, and it's usually much more efficient to run one command and just run everything at a shot through the command line rather than clicking on 100 different buttons and waiting to see the output. So you can be really efficient and do a lot of cool things using the command line. I mean, everything you can do graphically, you can do through the command line too. And so learning the basics, like navigating folders and opening stuff, running commands, that will take you really far, and it will make things feel much more easier, because at some point you will be using the terminal, and this is going to be very important for you. Now, I talked a little bit about the text editors. So what are the different text editors you can actually use? Because the default text editors are usually really bad. You don't want to use Notepad or TextEdit, because they don't have, like, although they do the work, it's going to be really hard for you to get far with that, especially on complex projects. So I'm going to give you a couple of suggestions. So a very good editor is Visual Studio Code. You can do a search for it, Visual Studio Code. It's an editor created by Microsoft. It's lightweight, and it does the job. It has a lot of cool features, and it'll help you get some good productive work. It could be a little overwhelming at first, but it does the job. If you want something a little bit more simpler, there is something called Sublime. I think this is paid if I'm right, but not really sure. I think you can, there's a free version too. It's a very simple text editor. As you can see on the left side, you have a list of files that are in that folder. You can click on one of those files and you can start typing. And the cool thing about these text editors, which are built for coding, if you see, it highlights them in different colors, so that when you have a huge, file with like 200, 500 lines of code, it can it really helps make it easy on the eyes, and you know which part of the code does what and where it is, because of this color coded highlighting. So that's one of the main advantages of using these code editors. So these are code editors. And then there is one more thing that I want to highlight, and that is version control. So at some point you're going to be collaborating with others, and you're going to be working on projects. Even if you work on a project by yourself, there's something that's very important you need to understand, and you will be using it forever if you're in this field, and that is version control. You would have heard of something called GitHub. I'm going to go to github.com. Very popular tool, and I'm going to explain what GitHub is and what version control is. So there's a very popular version control tool called Git, Git, and I think this is installed on my computer. You can see it says Git version 2.39.3, Apple Git 145. So this so Git was already pre-installed by Apple on this machine. If you are on Windows, usually would not have Git. I recommend you installing it by going to git-scm.com. If you go over here, you have an option to download. If you're on Mac, you don't need this, but if you're on Windows, I would really recommend installing this. So what is Git? Git is a version control system, and what it does is it helps you keep track of the version of your project. So let's say you're working on a coding project, and everything's working, but you add a new line of code and suddenly everything stops working. You don't know what happened, and you want to go back to the previous version, but you don't know how. Git can help you do that. So with Git, what you can do is periodically you can decide what files you want to track, which files you've made a change and you want to create a new version of. So you stage those files, you add those files to a staging area, and then you say, okay, I've modified these files, I've created a new version, please I want to commit this change, I want to create a new version, and you give it a message, right? So periodically you do this, and you have a log. You can see the progression. So every time you make this commit, you create this new version, you can see the message that you gave. Okay, this time I added this feature, this time, okay, there was a bug, there was an issue with my code and I fixed this, next time I did this. So you have this progression, and you can see your messages you've provided every time, and this is a new commit every time you're making a new version, right? So at any point of time, if something goes wrong, you can always roll back to the previous version. That's the beauty of this. And what makes this even more powerful is the concept of branches. So you can create a branch. So let's say you're working on a new feature that could go wrong, right? You can create a new branch so that is unaffected by the other branch, the main branch. So let's say if something goes terribly wrong, you want to scrap it, no problem, delete the branch and you can get right back to where you started. But if everything works successfully, then you can merge this branch onto the main branch. So now you have the best of both worlds. So it's really cool. You can do some cool stuff with it, and you will be using this throughout your career if you get into this field. And it's very important to understand how it works. I'm going to create a separate tutorial on how to use Git and GitHub, but I want to talk to you about what it is and give you a starting point. So you can go ahead and download it. You can search up YouTube videos for now, and just see where it takes you. This is very important. The other part of it is GitHub. So it's important not to confuse the two. Git is related to GitHub, but they're two separate things. So Git is a version control system. GitHub is a place to host your projects. Now the reason why it has Git in the name, it's because it uses Git. So what you can do is, let's say you're working on a coding project, you use Git, right? So you use Git on your system and you use it regularly, so that creates a Git repository. It creates a repository that tracks all of these changes, and it does all of this cool stuff for you. Now GitHub is a place where you can host a remote repository of your code. So you can push your code to GitHub, and it also uses Git behind the scenes. So you can see the different commits, the different versions, the branches on GitHub too. And the advantage is, let's say something terribly bad happens, your computer crashes, all your code is on GitHub. So it's like Google Drive but for code, kind of. It's a really gross simplification, but that's kind of what it's doing. And it's much more powerful when you work in teams, because let's say you're working with a friend on a project. What you can do is you can push your code to GitHub, and then your friend can pull it from GitHub. Every time you make a change, you commit it, you push it to GitHub, then your friend pulls it from GitHub, works on his changes, then he pushes to GitHub, then you pull from GitHub. So it's a cycle like this. So you can do some cool stuff. That's why GitHub is very important. I hope this gives you some clarity on why people use GitHub. I feel a lot of people have a misunderstanding. They all have heard about GitHub, but they don't really actually know what it's used for. I mean, you can do a lot of other stuff with it, but this is the essence of it. So if you haven't already, go sign up for an account. It's called a repository. If you go to product, I don't know if it's over here, but let me try searching for my username. So this is my account. So you can see I have a couple of repositories over here. So you can create a repository, and then your code is over here. So this is exactly the same, the code that you have on your computer. You push it to GitHub, and now you can view the code over here. Now in this case, it's public. Everyone can see my code. If you want, you can make the repository private, so it's only for you. So this is why you use GitHub, this is why you use Git, and this is something that's very important. No, I'm thinking I'll create a separate video just on how to use Git, the basics of Git, the basics of GitHub, so that might be helpful. But I think for now this is pretty much it. I hope this was a brief yet um, simple and helpful understanding of the intro to computer science. What actually no, I wouldn't call it the intro. This is kind of the setup, right? Let's say you've committed yourself, you want to learn something, right? I wanted this video to be a good starting point. What do I need to get started? What are the different tools I need to get started? What should I know in order to get started? So I hope this was helpful. Thank you for watching, and if you have any questions, please feel free to let me know in the comments or contact me directly. Once again, thank you for watching. I'll see you in the next one.